Sorry about the bit of delay. I have Shyam with us here with me on the Hangout. Shyam, do we have other people who are joining in? Can you hear me? Shyam, do we have other people who are joining in?
हाँ भैया मैं ऐड कर रहा हूँ. आप खोलते रहो, मैं और ऐड करता रहूँगा, आपको पता चल जाएगा. ओके.
All right, cool. So we have 7 viewers already. I'm just gonna wait for another couple of minutes for people to join in. Cool. So I'm just gonna start off. Hi guys, my name is Rohit. I'm good. So as you guys must be aware, as part of having some videos around how to get started with Linux, we are doing a series of webinars where we're gonna pick up one of the topics and give a small talk about it, and people can just go ahead and take a look at the videos at a later time. We are going to have them every week, most probably, but let's see how it goes on. So as some of you might be aware, last week we did a webinar on Introduction to Linux. Anurad hosted it, and uh, he talked about how Linux started off as a project and how it evolved over a period of time, and how is it doing now. So in case you guys are interested in looking at it, you can go ahead and check out the video on our YouTube channel. So as the next step today, I'm going to do a talk on Introduction to Bash. So once you get acquainted to what Linux is about, what is the essence of Linux, and how essentially it's just an operating system. But once you get started, the next step is that how do you start using it? Now, in today's world, Linux is actually having a lot of graphical user interfaces which are pretty nice, and they are very close to what you would have on other platforms as well. But even then, the bash is like a very important part of it. Bash is just a shell which acts as an interface between the user and the kernel of the operating system. So it's the logical next step to learn about bash. Hi, Tarun. Can you just mute yourself? Okay, awesome. Thanks. So we are hosting this webinar to kind of talk about Introduction to Bash. I'm quickly gonna. So this demo is kind of going to be like a very basic introduction about Bash. I'm gonna talk about what Bash is, how it evolved, and then what are the different terminologies, how can you use Bash. I'm going to also give a demo by using the command line terminal side by side. I'll be presenting from my laptop. If you guys have a laptop with you, you can probably try out the commands on your own. But it's okay if not, you can probably try it out at a later time. Uh, so let me just quickly present my screen and get started with the presentation. Cool. So basically, what is Bash? What is a shell? Now, uh, as you know, Linux is just an operating system like any other operating system, right? Bash happens to be one of the shell which lets you interact with the kernel of the operating system. You can operate a lot of operations while using the graphical user interface, but since the Linux was supposed to be uh, something which is usable not only by the graphical user interface but also from command line, uh, there was a need for a shell which was rich enough and which was versatile enough to perform all the operations. So Bourne shell, which is commonly known as Bash, is the most popular shell out there in the Linux world in today's time. There are other shells available as well, like SH, ASH, ZSH, KSH, uh, which have been used and which are being used by different people as per their requirements. Uh, Similarly, this was the as you can see on the presentation, the Bourne family shells. There are 5 different Bourne family shells, right? They fall in one single category because they are very similar to what Bourne had initially written uh, in the early phases of the writing of the shell. There are C family shells, there are Perl shells. Even in the Microsoft family, there are different shells available. Like recently, Windows PowerShell was launched some time back. Command.exe is like a pretty old one, and I hope pretty much everyone would have used it at some point of the time. So what does that mean? Like once you have the shell with you, now what are you going to do with it? Now shell, as I mentioned, is an interface, right? Once you once you are in the on the interface, then you would like to do different operations, right? You would like to kind of interact with the operating system or probably get things done. So for that, there are a lot of commands which have been defined within the shell. So here are some of the built-in commands which are there on Bash, and they let you do various different operations to manage your operating system and do your daily job. So, for example, let me quickly try out uh, history command for example, right? If you can probably see my screen here, let's say if I try out history. So it'll show me that what are the commands that I have executed in the past. Uh, let's say I execute, uh, uh, for example, what do we have here? Let's say CD, for example, right? CD. Okay, I don't have a directory created on this machine. Let me create a directory, right? So directory, as you know, that like creating a folder, right? So for example, I want to create a folder on my machine from a terminal. I can simply do mkdir uh, first folder, and I have a directory created here. If I'll do ls, I can see that there's a example file and there's a folder created right here. Now if I want to change, cd basically stands for change directory. I want to probably go into the directory and see what all is there inside the folder. I can just do cd first folder and I am in. If I will do an ls, there is nothing inside the folder and it's blank as I just created the folder right now. Similarly, there's a complete list of commands who do a lot of different things, right? Um so these are the built-in commands, which means that even if like you have a blank system, you just have one shell created, these are the commands which will be read by the kernel by default. You don't really need to do anything on the system to have them. But what about the non-built-in commands? So like, for example, you just saw that I used the ls command here to kind of list the files in my current directory, right? uh, so that is actually a non-built-in command. What does that mean is that this particular command has been created by someone. It's basically a binary file and which is residing on the system. But you'd be wondering that like how does it matter to me? What difference does it make to me? How does it matter is that in different versions of operating systems, sometimes some of these commands differ in the way they work. So for example, ls may behave in a certain way on one distribution, but some of the parameters which you pass on ls might differ on other operating systems. The differences are very minute. Most of the time they are very constant and you will not feel the difference, but you never know. There might be a distribution which has a different version of it. So basically, they might end up behaving in a different way as they would on a different system. So similarly, there are a lot of different system commands which we use commonly in doing the different operations, but they do not. Uh, but they are not really built into the system. They are external binaries which are provided as part of the operating system to perform your daily task. But you'd be wondering that what is the difference between the built-in commands and the non-built-in commands? Usually the non-built-in commands would end up using the system calls of the built-in commands. So for example, here in the built-in commands, if you see that there is read, there is printf, there is history, there is echo. So these are all different smaller functions, and they are often used by these commands to perform a given task. And they actually provide a layer on top of the built-in commands. Now, uh, so once this is done, what is the next step that you would like to do on your system? Well, you know that, okay, if let's say I have a file which I create by using vi editor. Let's say I create a sample file. And I say um, hello, and I just save it. Now, what if I want to execute this particular, like, what if I want to display the content of this particular file on my screen? I would simply do cat sample file, right? I would print whatever is there in my file. But then, what if there is something in one of the files which I want to kind of show every time I'm logging in? Or probably there's a system configuration that I want to take place every time I log into the machine. How do I go about that? Now, to achieve that, within the bash, there are some configuration files which you can configure as per your need, and they are called special files. Uh, the point of having those special files is that they provide you with a configuration which is very customizable to how you want to do certain things. So for example, let's say every time I log into the system, I want to let me think of an example. Let's say I want to get the time, like the current time which is there, right? So for that, there is already a command called as date, which is built in, right? But what do I want to, like, what if I want to see this time every time every time I open a new shell? So what I can do for that is I can just go to uh, the bash login file and create a quick entry. So I need to go back to my home directory, and then I will do vi. Okay, so here are the files which I have. So I have bash logout, I have bash rc, I have dot profile. I do not have dot bash profile. Create one. And let me do cat, sorry. Date. And let me just do bash. What am I missing here? Jar dot bash rc. Hmm. It has not over bash, so let me just do in this bash profile itself. Okay, I think something is messed up on one of my machine, or I'm doing something wrong here. But anyway, so these are the files that you can actually configure to kind of get your system to execute some of the commands while you're logging into your shell. Similarly, .bash logout is the file which gets executed when you are logging out of the system, and like, let's say for example you want to kind of delete a particular file, you can probably give in a command over there. So let me try out if my bash logout works fine. So I created a file called a sample file when I was showing the demo earlier. Let me just do .bash logout. Let me just do rm. Sorry, where did I put it? Course folder sample file. first folder slash sample file, and let me just do bash, and then I execute logout. Oh yeah, so logout, not login shell, exit. Let me just see if we have the file there or not. First folder, and the file is still there. I think my bash file is messed up somewhere, and it's not gonna help me out today. That's embarrassing. But anyway, you can fiddle around these sample files. There are resources available online pretty easily, and you can configure them, and they help you kind of perform some of the operations while logging in and while logging out of your system. Probably if you want to set up color for your terminal and things like that, they can be easily doable from there. Now, just like every other system or programming language, right, there are always some reserved words which you cannot usually use as variables, right? So similarly, they are present here in Bash as well. And they can never be variables. So these are some of the very small examples like time, then, select, while, for, do, because these are the reserve words, and you use them to kind of write smaller programs, which I'll show in my next demo really quickly. So in case you are trying to write a sample script, or if you're writing a program, just avoid these words because they actually perform logical operations while doing things on your bash. Now, while you're using the command line, you need to also know that how to navigate really quickly on the terminal, right? Because ultimately you don't want to end up doing a lot of typing and a lot of use of arrow keys in case you want to do something. And when you'll be writing commands, sometimes they'll be like really long. So for that, there are really quick shortcuts which are available. So let me just show you. Like for example, I'm typing out I want to change directory to uh, my first folder, and if you would have seen, I just completed the folder name right away. So all I had to do was I just typed in F. So there is something called as auto completion on tab. So if I would start typing, I would say FIR and I would just hit tab, and it would automatically complete the rest of the uh, file, which is matching the regular expression at that particular time. And as you would have seen that it completely typed in the whole thing. Now, if I hit a tab again, it's gonna, it'll not do anything. But if I'll type in, oh, okay. So I think it actually did delete my file. What? Okay, yeah, sorry. I didn't see this. So let's say I'm trying to change my directory to the first folder. I just need to type in first, and then I'm trying to. I was earlier what I was trying to do was I was trying to change directory into the file, which is obviously really stupid of me. And now I need to kind of go ahead and change my initial command, right? So what I'll do is I'll simply do Control A, and I'm at the beginning of the command, right? I'll simply do ls, and now I need to go back to the place where I was typing, right? And I just hit a tab again, and voila, my file is complete. So if I do ls, it basically lists the file name right away in front of me. So I didn't really have to go ahead and delete the complete section over here saying first folder in order to achieve this. I can simply click LA, I just delete these two lines and I say MV, and then I need to figure out where I want to move this file, right? So I would go to the end of the line really quickly, and I'll say dot, which basically means where the directory at which I'm in right now, and it's done. So my sample file has come out of the first folder, and if I'll do ls first folder, there would be nothing because I just moved the file. Similarly, you can use the arrow keys up and down in case you want to look at the history. Let's say, for example, I want to open, uh, uh, I want to execute date command, which I did a while back, right? So I can just go ahead and do it in the history. Oh wait, I lost my history because I changed. I was doing it in a different hash. But yeah, there are other commands which are still available. And as you would have seen that my complete screen became clear right away. So there's a shortcut for that as well, which is Control L, and that clears the screen. Uh, I want to uh, execute the last command. I just do tada, and it lists the folder which I had done. If you remember just now, here I had done the ls command. So that. Having said that, what all can you actually do on Bash? Now, this is really cool part of using Bash all the time, and that is on Bash you can actually write commands and you can actually write small programs without having the need to do anything special about it. So let's say, uh, as I have already included in the presentation, that for example, let's say you want to print 1 to 10, and you know if typically you are writing a C program, or if you are trying to do it in any other uh, language, probably not Python. Yeah, that would be like a bad example of doing it. But then even for Python, you need to open an interpreter to in order to actually do it. But here in Bash, you can simply go ahead and do it on the terminal, like for I equals to 0, I less than equals to 10, I plus plus, uh, do echo $I, done. And here you go. So it went into a loop, it executed for, and it printed the numbers from 0 to 10. If you remember, sometime back when I was talking about it, reserved words, right? If you would notice, for was part of one of the reserved words. And I think now it would kind of make sense that why we actually have reserved words and they should not be used as variables, because they actually perform operations like the ones that you saw just now. Like I did a do, I did echo, I did done, and this is how the syntax of a given program follows. And that is the reason why you should not be using them as reserved words, because they are going to create problems. Similarly, there's a small program for writing Fibonacci series till limit. Let me just quickly see if I can copy it. That saves me some typing time. fibo.sh. Now, while you are writing a bash script, so like I was mentioning that there are already a few configurations present in the OS that I'm using right now. If you see here, there is already a hash shebang. So this particular line is called shebang, and it basically tells the interpreter that this is a bash file, and you should be interpreting it as a program and not like a simple text file. Usually, if you'll be using hash, this particular hash, it would comment the line in bash, except for the exception of this particular line. So don't get confused. If you are writing this doesn't mean that this will get commented, but this will actually be read by the interpreter and used performing the operations. Okay, I copied this by mistake. and here. So here, I'm sure some of you might be aware with Python, but uh, unlike Python, it does not really care so much about the syntax as long as you have put in the semicolons and you have defined the variables correctly. Um it's usually not all that problematic, but for the sake of readability, let's do this. So, like I was mentioning, I need to go to the uh, file, and I need to add this. So that kind of makes sense to everyone. Cool. I'm going to write it out. Just so you know, if you would see the program over here, there's something called as $1 here, right? Uh, Now you must be wondering, what is $1? Now, $1 is a special symbol in Bash, and that actually means the first argument which is being passed during the execution of the file. So, for example, uh, let me just quickly do uh, echo $0. Okay, and I'll write it out. Now, since I've created this file, in Bash, since it's the Linux operating system, what happens is that any new file that you create does not have permissions to execute it, which means if you have to execute a particular file, you need to give them the permission, which is done by chmod. It's one of the commands, and I'll do +x. Okay, so if you would see over here, when I did tab, it showed me the different options which are available, right? Because it doesn't know which one it should actually take an action on. So I need to type in the third alphabet as well and say FIB, because that's how it differs. So this one is FIB and this one is FIR, right? So if I do FIB and then hit a tab, it automatically completes it. So now my file is executable, and let me execute uh, sh fibo.sh, and uh, that's it. So if you see over here, it did it printed the file name, and then it said, well, line number 5, syntax error, operand around blah blah blah. That is because uh, $0 basically represents the file name, which represents the command itself which is being executed there, and then uh, the second argument, which is $1, represents the first argument that is going to pass to it. So let's say I want a Fibonacci series till, let's say, 30. Okay, just trying to keep it short here. So it printed the file name there, and then it printed 1 1 2 3 5 8 13 21. It did not go beyond 21 because 21 plus 13 is gonna shoot out of 30, which we had pretty much written in our program. Let me just go back here, vi fibo.sh, and here, while second is less than 1, uh, we were just trying to do a Fibonacci series print. So these are just the basics that I had for this presentation. If you guys have any questions, feel free to shoot out in the comments or in on our Telegram group. All right, so we have. So by the way, so here are some of the links which you can actually go to quickly. Uh, they are pretty good. They have pretty good documentation and resources about how to get started with Bash programming. Uh, di- they have divided the whole chapters in very small sections, which go step by step and cover all the aspects of Bash programming. Uh, so I have a question which says, how does OS figure out what file is it? Uh, how does OS figure out what file is it? Good question. So what happens in Linux operating system is that it treats each and every one file as a simple text file, um, or basically they are bash files. So what happens is that uh, there are primarily two types of files. Actually, there are more than that, but at least to get started for now, uh, there are two kind of files. One are binaries, and then there are others which are usually the config files or the regular files. Uh, in in Linux, pretty much every file is treated as a regular file, even if uh, it's a program. There would be like shell programs, and you can just read them. Unlike unlike the other operating systems, like for example Windows, right, where you would have a lot of compiled library files and a lot of binary files. Of course, Linux also has binary files, but uh, usually you will uh, not have, uh, unless of course you are into OS development and you are trying to do something uh, related to OS development, you will not run into a lot of binary editing or the driver editing, which are .so files. Uh, I hope that kind of answers the question. Hmm, cool. Do we have uh, other questions or cool? I don't think. Okay, Sham is typing something. All right, so we don't have any other questions. I'm gonna put the link to the presentation in our in our video description in a bit, and you guys can take a look at it at a later time, ask questions, and feel free to uh, have a discussion on either our Telegram group or Facebook group or YouTube channel. Okay, we have another question. How does a shell work? Okay, so if you would remember how the operating system is designed, usually you would have hardware at the bottom, which is going to perform all the operations. It's going to uh, basically do the actual hard lifting uh, of the computer system, right? On top of that, our kernel uh, uh, acts as an interface. It basically controls our hardware by doing by sending it low level commands, by having drivers which acts as a base for the higher level services. On top of the kernel, we would have a shell. Shell uh, Basically, shell and applications both come at the same level in some of the operating systems, and on some operating systems, uh, applications are on top of the shell is itself. So you can think of the shell, which is actually interpreting what you are saying into a language that is understandable by your kernel. So kernel would have very low level system commands like printf. It would have uh, stat command to kind of do the file operations. It would have a lot of C binaries. Now, while you're writing a program, you don't want, like, you would not be doing all of those in a kernel understandable format, right? If I need to print a Fibonacci series, I would do it in a language that I understand and not uh, what system understands, right? So for that, the shell acts as an interpreter, and uh, it interprets what a human would say in a defined syntax, and then send the appropriate commands back to the kernel, and the kernel would take the operation will take an action on it, and it'll send the reply back to the shell, and it will interpret it back and put in the results in a proper format for you. Can we write custom shell commands? uh Custom shell commands, interesting question. So as I mentioned that, if you look at my presentation, right? So there are, where was that? Yes. So there are two kind of commands over there, right? One is the built-in commands, and the second one is the non-built-in commands. Yes, you can create any one of these custom binaries. Probably you can pick up the source code of, let's say, for example, cat, right? You can pick up the uh, source code for cat, and then what you can do is you can simply modify the source code and rebuild the binary and replace that binary in your operating system, right? And that's going to work the way you have defined it. Yes, you can obviously do that. But when you talk about the built-in commands here, uh, the built-in commands are basically embedded into the shell. So for that, you will have to rewrite the shell itself and recompile the shell, and then install that shell on your machine. So if you remember in my presentation, we were talking about the different examples of shells, right? So there are Bond family shells, there are Perl family shells. So of course, all these shells have their own built-in commands. Some of them are very similar, but some of them have variations. They're available on internet. You can read about them. So yes, if you want to write custom shell commands, the answer is like two-phase. One is that whether you're trying to build the uh, inbuilt commands, or you're talking about the other ones, the which are the non-built-in commands, which are like the external binaries. I hope that answers the question. Is shell programming different from low-level programming? Yes, very different. From if I understand your question correctly, by low-level programming, I am very sure you are referring to the kernel programming. Uh, Bash is only going to help you out as an interface. Like uh, you would be mostly doing the uh, writing of the code. For example, like I wrote the code for Fibonacci, right? Similarly, you'll be writing the code for the kernel, and you'll require interface. You'll require a place where you can compile your code, and you can run other binaries in order to do your programming. But yeah, that's about it. Low level programming would require you to understand the internals of the kernel. It would require you to understand C++, because a lot of code that we have for Linux is actually C code. So depending upon what particular module you are interested in, you will have to go about it and read it. It's, yes, it's different from the bash programming. Bash programming is more like uh, bash programming is more about doing your system administration, doing uh, your day-to-day task. So, for example, I mentioned that you can configure your .bash rc and .bash profile files, right? So they are nothing but uh, files which get executed the moment you log into the system. So let's say uh, you want to greet all your new uh, users, like every time they are like if every time there's a new user on the system and they log in for the first time, you want to say you want to probably point them to a dog saying that, hey, you need to be careful about blah 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 policies, go here and read them. So yes, that you can get done via bash, that you can configure in your system, and that you can implement via bash, that if it's the first login on the system, then perform these operations. uh, but uh, uh, yeah, I mean, low level programming is different. Bash is different. Bash is more about system administration. All right. Any other questions? Then what's the difference in shell programming as compared to low programming in terms of performance extensibility? No such thing in shell, right? Okay, so the question is, what's the difference in shell programming as compared to low-level programming in C, etc. In terms of performance, extensibility, uh, no such thing in shell, right? Uh, so both of them are serving totally different purposes altogether. First of all, I don't think there is a term called as low-level programming, or is there? Yes, so there are low-level programming languages, but I don't think there is something called as low-level programming as such in itself, right? Low-level programming languages would usually involve a lot of machine code, assembly language, and a lot of uh, uh, compiled programming, where you would have packages that you need to configure and you need to deploy on a given system, because that is the code which is actually dealing with your kernel and your controllers that you have on the hardware, right? So like for example, the drivers for different operating systems, so they would usually use a low level programming language to perform their task. Like we cannot use Python to write our uh, kernel modules, or probably uh, what should I say, uh, drivers, at least for now. They are not really common. uh, you would usually use C to perform that, because it has extensive support, and that's how the kernel is more tweaked towards, so it would give you better performance if you're doing that. uh, Wait. Yeah, so I hope that answers the question. uh, no such thing in shell. Shell is more for your day-to-day operations, your uh, actually it's actually going to cover. So the next question actually we have is, can we use shell scripts for automation? How is it different from different automation tools available like Selenium, etc.? uh, okay, so I'm gonna break this into two parts, I would say. Can we use shell scripts for automation? Yes, shell is used a lot for automation. Uh, like the example that I just picked, where you can have uh, shell perform operations while you're logging in, or probably you can actually uh, schedule some of the jobs to execute at particular interval. They are called cron jobs, and there is support provided by that for the operating system already. You can just go ahead and configure a cron file, and it will execute whatever command you want them to execute at a given time for a given user, provided you have the appropriate privileges. So yes, Bash is used extensively for automation as well as system administration, because uh, like you saw that I was using this terminal uh, to access my Linux, right? Now, my Linux server is hosted remotely. It's not running on my local machine. I need to connect to it, and I will not have access to graphical user interface all the time. And if I need to perform operations, it's easiest and quick to do it over SSH, because uh, it's just command line terminal. It doesn't really require a lot of bandwidth, and you can make your connections really quick. How is it different from automation tools available like Selenium? I would say that there are different uh, usage of different applications. Selenium, if I remember correctly, happens to be one of the testing automation tool. I might be wrong, but that's what I remember. Yes, so Selenium is a testing framework for web applications, right? Uh, but what if, let's say, you want to figure out what is the disk usage on your server uh, every night at 10 o'clock. One is that yes, you can log into the system at 10 o'clock every night and see what is the disk usage. But what if you don't want to be awake at 10 o'clock in the night? You can just simply write a script. You can put it in the cron job, which I just mentioned about, and it will run that particular command at the time that you mentioned, and you can store that data in a log file. So next day when you get into the office, you can say, oh well, last night the disk usage on my server was very high, probably because of blah 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 reasons, and we need to take a look at it. So yeah, you can automate a lot of things on the system. You can actually control your complete operating system from your terminal itself. You don't really need any graphical user interface whatsoever if you are using Linux. Uh, you can even respawn. There is so much support available now that you can even respawn virtual machines on your Linux. Excuse me, on your Linux machine using just the terminal, because they have command line utilities available for them. You just pass on the parameters. You define a configuration file that, okay, I want my virtual machine to have uh, let's say 10 GB of hard drive and 500 MB of RAM allocated, and you're just going to put in the configuration file, and you'll just say spawn my virtual machine, and in like 5 minutes you'll have a new virtual machine running. Okay, the next question is, I never understand the concept of pipes. Can you give examples? Uh, okay, let me just quickly think of a nice pipe example. Uh, okay, yeah, so this is a really quick one. Let me just quickly go back in the present mode, and I hope that would help. Entire screen share. Okay, cool. I hope you can see my screen now. So let's say, so over here, if you see that I have one file as .sh, let me create another file which is uh, test script.sh, and let me create another file which is dot, which is let's say a text file, notes.txt. Okay. Now pipes, right? Let's say I do ls, so it's going to show me pretty much. Let me increase the make text bigger. Here.
It's 11 o'clock.
Okay, so let's say I did ls and it showed me all these files. Now what if I want to only see the files which are my bash script files? So I'm going to put in a pipe and I'm going to do grep star.txt. So let me explain this command before I execute. What it means is that whatever the output of ls is, we are going to send that output as input to grep, and then grep is going to perform the regular expression match like it always does, and it's going to say star dot txt, which means any file name which ends with .txt. If I execute, it gives me no .txt. I go back and I say .sh, but huh, yes, weird. I think this is one of the gotchas that you would have in OS. It's not detecting star.sh, but it's grepping.sh. Uh, Damn, you should never use a new computer for a demo. So yeah, as you can see that whatever the output of the first command was, that went to the second command as an input, and then it executed and gave the output. What else? Basically, pipes are just this. They just help you out, forward the output from one to another. If I put another output here and I say grep fi, so it's only going to give me the output of fibo.sh. Let me just create another file called as touch file. So now I have all these files. Now if I'll do ls grep sh and then grep fi, so what would happen is that it's only going to show me fibo.sh, because when I did ls, it basically found out all the files which were here, so which included examples.desktop, fi, fibo.sh, first folder, notes, sample file, and test script, right? And then I only grabbed the sh, which means like if you see here, I was only supposed to get these two results. And then if I further grab fi, I'm going to only get fibo.sh. So the output of first became the input of second, and then that became the input of third. If I would simply do ls and then do grep fi, it's going to show me all the four options that I have available here. I hope that answers your question. Cool. Anything else? We have almost hit our time. All right, so let's call it a night. Hope you guys would be able to uh, go ahead and start with the next steps. We are going to have more webinars in our series, and we would try about next questions. You would be able to see uh, the invites on our different forums that we have. All right, so thank you so much for dialing in, everyone. We are going to sign off, and cheers. Happy learning. Good night.